Okay, what's up everyone? Today I'll be listing out all the main parts of a PC and what they all do to help the PC run.
At night, the lonely loner seems to free his mind at night. At night. At night.
As some of you may know, there are 5 main components towards building a PC. These 5 components are the CPU, the motherboard, the GPU, the RAM, or memory such as the solid state drive or the hard drive disk. First off is the CPU. The CPU is the brain of a computer containing all the circuitry needed to process input, store data, and output results. The CPU is constantly following instructions of a computer program that tells it which data to process and how to process it. Without a CPU, we could not run programs on a computer, or I think the PC will run at all. What is it made of? At the hardware level, a CPU is an integrated circuit, also known as a chip. An integrated circuit integrates millions or billions of tiny electrical parts, arranging them into circuits and fitting them all into a compact box. Motherboard. The motherboard is the backbone that ties the computer components together at one spot and allows them to talk to each other. Without it, none of the computer pieces such as the CPU, GPU, or the hard drive could interact. Total motherboard functionality is necessary for a computer to work well. If your motherboard is on the fritz, expect some huge problems like, random crashes and all that. Common motherboard parts. Parts of the motherboard include power and data connectors, capacitors, heat sinks, and fans. You may also see screw holes for adding a new part or for anchoring it into a device. The pieces that are plugged into it, either with wires or directly, are often called motherboard components. These include optical drive, such as a DVD or CD-ROM, which there's hardly see these days, video card or the GPU, sound cards, hard drive, like the SSD or the HDD, processor, CPU, or the memory stick, basically the RAM. In short, if a computer uses it to function, it's probably connected to the motherboard so that it can coordinate tasks with other computer parts. Without the motherboard, nothing happens as it should. Now onto the GPU. The graphics processing unit, also called the graphics card or video card, it's a specialized electronic circuit that accelerates the creation and rendering of images, video, and animation. It performs fast math calculation while freeing up the CPU to perform other tasks. There are 2 kinds of GPUs. One is an integrated or embedded GPU that lives directly on and shares memory with the CPU, and the other is the discrete GPU that has its own card and memory. The GPU is an extremely important component of a gaming system, and in many cases even more crucial than the CPU when it comes to playing certain type of games. So basically, all your new games coming out recently, you wouldn't be able to run it perfectly on a CPU alone. What's the core difference between a CPU and a GPU? While a CPU uses several cores that are focused on sequential processing, a GPU is created for multitasking. It has hundreds to thousands of smaller cores to handle thousands of threads simultaneously. Now we're on to the RAM. Computer Random Access Memory, or RAM, is one of the most important components in determining your system performance. RAM gives applications a place to store and access data on a short-term basis. It stores the information your computer is actively using so that it can be accessed quickly. The more programs your system is running, the more you will need. The speed and performance of your system directly correlates to the amount of RAM you have installed. If your system has too little RAM, it can be slow and sluggish, but on the opposite end, if you install too much, there will be little to no added benefits. So, for most people, having more than 16 isn't making much sense. RAM performance is all about the relationship between speed and latency. While the two are closely related, they are not connected in the way you might think. At a basic level, latency refers to the time delay between when a command is entered and when the data is available. Understanding speed and latency of RAM will help you better choose the right RAM to install in your system based on your needs. Next we have the storage. The technology behind the hard disk drives is well known and well tested. They have been around for more than 50 years, steadily increasing their storage capacity and decreasing their physical size. The hard disk drives relies on spinning disks or plotters to read and write data. Hard disk drives consist of one or more magnetically sensitive plotters and actuator with an arm with a read-write head on it for each plotter, and a motor to spin the plotters and move the arms. There is also an I/O controller and firmware that tells the hardware what to do and communicates with the rest of the system. The plotter spins at preset speeds 4200 RPM to 7200 RPM for consumer computers. Those speeds are correlate to read-write rates. The higher the preset speed, the faster a hard drive will be able to read and write data. Lastly, now onto the memory I prefer, which I think is way better. Solid-state drives. Solid-state drives use flash memory to deliver superior performance and durability. Because there are a lot of small moving parts inside your hard drive, magnetic heads, spindles, and spinning plotters, it's easy for things to go wrong and you can lose your important data. Without moving parts, SSD are more durable and run cooler and use less energy. Why choose a solid-state drive? Solid-state drive delivers faster load time for games, applications, and movies. Because of the technology they use, SSDs are lighter and better able to withstand movement or falls. I want to thank everyone for taking the time out of the day or night to look at this video. Hope you guys learned and enjoyed. Stay tuned for more. Thanks.